In this video, we will explore access control lists, also known as ACLs. ACLs are a powerful tool that extends the basic Linux permission model, allowing for more advanced and fine-grained control over file and directory access. We will cover what ACLs are, why you might need them, how to use them, and some best practices to keep in mind. So, what exactly are access control lists? Think of them as an extension to the traditional Linux permission system. While standard permissions allow you to set access for the owner, the group, and others, ACLs let you define permissions for multiple specific users and groups. This provides you fine-grained control beyond the basic owner, group, and others. The advantage is that you can specify exactly who has access and what type of access to specific files and folders. ACLs are implemented in most modern Linux file systems, like Extension 4 and XFS. Now let's explore some scenarios where access control lists come in handy. Consider a shared project directory. Different team members might require different levels of access to the same files and directories. Basic permissions simply cannot provide the flexibility. In scenarios involving complex data access where multiple users need varying read, write, or execute permissions that don't neatly fit into the owner, group, others model, ACLs are very useful. If you need to grant a specific user temporary access to certain files without permanently changing group memberships or the basic file permissions, then ACLs are the way to go. Finally, ACLs allow you to set default permissions for all newly created files and directories within a specific directory, ensuring consistent access control throughout the project. Before diving into using access control lists, make sure these prerequisites are fulfilled. First, your file system must support ACLs. Common file systems like Extension 2, Extension 3, Extension 4, XFS, and BTRFS all support ACLs. Secondly, ensure that the necessary ACL packages are installed on your system. Thirdly, the file system should be mounted with ACL support enabled. Most modern Linux distributions enable this by default. Lastly, you should have a basic understanding of the standard Linux permissions model, including read, write, and execute permissions for owner, group, and others. Here are the commands you can use to install the required packages depending on your distribution. You can use sudo apt install ACL on Debian or Ubuntu. On Red Hat or CentOS, use sudo yum install ACL. To check if your file system is mounted with ACL support, you can use the mount grep ACL command. Usually ACLs are enabled by default. If not, you can add the ACL option in the /etc/stab file. Let's go over the basic commands you will use to manage access control lists. To view the ACLs for a file or directory, use the getfacl command followed by the file name. This will display the current ACL entries, including the owner, group, and any additional user or group permissions. Use setfacl command to set an ACL for a specific user or group. The M option is used to modify the ACL. Specify U for user or G for group, followed by the user or group name, the desired permissions, and the file name. You can remove a specific ACL entry using the setfacl command with the X option followed by the user or group name and the file name. To remove all ACL entries from a file or directory, use the setfacl command with the B option, followed by the file name. To apply ACLs recursively to all files and subdirectories within a directory, use the setfacl command with the R option. To set default ACLs that new files and subdirectories will inherit, use the setfacl command with the D prefix before specifying the user or group. Let's understand the permission notation used in access control lists. User ACLs define permissions for specific users beyond the file owner. Group ACLs define permissions for specific groups beyond the primary group. Default ACLs are inherited by new files and directories created within a directory. The mask limits the maximum permissions allowed for all named users, groups, and the owning group. Here is a table showing the different ACL entry formats and their descriptions. U username, RWX denotes a user ACL with read, write, and execute permissions. G group name, RX denotes a group ACL with read and execute permissions. DU username, RW- stands for default user ACL with read and write permissions. DG group name, R, stands for default group ACL with read-only permissions. M, RW- refers to a mask limiting permissions to read and write. O, R, refers to others with read-only permissions. Let's walk through a practical example of setting up a shared project directory. In this scenario, the project manager needs full access, developers need read and execute access, and the QA team needs read-only access. First, create the project directory using the dir command followed by the directory path. Second, set the basic permissions for the directory, giving the owner full access and restricting access for the group and others. Third, set the ACLs for the project manager, granting full access using the setfacl command. Fourth, set the ACLs for the developers group, granting read and execute access using the setfacl command. Fifth, set the ACLs for the QA team group, granting read-only access using the setfacl command. Finally, set the default ACLs for the directory, so that all new files and subdirectories will inherit these permissions. This ensures consistent access control for all new content within the project directory. Let's discuss how to verify and troubleshoot access control lists. To check the ACLs on a file or directory, use the getfacl command followed by the directory path. This will display the current ACL entries. Some common issues you might encounter include ACLs not working, which could be due to the file system not supporting ACLs. Use the tune2fsl command to check the file system's default mount options. ACLs not being applied as expected. In this case, you should check the effective permissions using getfacl command. A mask restricting permissions, modify the mask using the setfacl RWX filename command. Here are some best practices to keep in mind when working with access control lists. Always document your ACL structure. Maintain documentation of your ACL design and implementation. This helps with troubleshooting and ensures consistency across systems. Use default ACLs. Apply default ACLs to directories to ensure that new files and subdirectories automatically inherit the appropriate permissions. Whenever possible, prefer group ACLs. Use group ACLs instead of individual user ACLs. This simplifies management as users can be added or removed from groups without modifying the ACLs. Perform regular audits. Periodically review and audit your ACLs to ensure they still meet the security requirements and remove any unnecessary entries. Let's summarize what we've learned about access control lists. ACLs extend the traditional Linux permission model, allowing for more granular access control. The key commands are getfacl and setfacl, used for viewing and setting ACLs. Default ACLs ensure that permissions are inherited by new files and subdirectories. ACLs are essential for managing complex permission scenarios in multi-user environments. Always document your ACL structure and perform regular audits to maintain security and consistency. For further information, refer to the man pages for getfacl, setfacl, and ACL. You can also refer to online resources such as the Linux Documentation Project, Red Hat Documentation, Ubuntu Wiki, and Linux Academy. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.